Hello everyone, welcome to pyrevise. Now we are going to talk about SYS and OS module in Python. SYS module helps us with interacting with Python interpreter. So we can do Python interpreter access Python interpreter functions using SYS module. You have to import SYS first. sys.argv, So let's say you pass some arguments to a file. Usually you do with the shell, and then you pass parameters or arguments. Same you can do with the Python file, py file, and pass some arguments. Then you can access them using sys.argv. Like this is your Python file. You pass them param1, param2, param3. Then you can access them as they are available to you as a list. First is file name, then all the params. So you pass to the main method using sys.argv from one, slicing it from one, that is from param1, param2, and furthermore. So if you are having this param you want to use as minus or minus option, you use minus, let's say minus b is equal to this minus c. So they use getup or argpark model in Python for better accessing this. Then standard in, standard out, or standard error. These are file objects corresponding to Python standard input, output, and error string. You can use them whenever you need a standard input, a buffer input, a standard output. You have to put something on standard out. So you need a standard error. And let's say you are passing in a command, and then you want to get out standard in, standard out. You can use them. Sys.version, it gives you a Python version, something like this. First version, then additional information about build number, the date, and the compiler used. So this looks little messy. So you can use system version info. It gives you a major 2, minor 7, micro 13, that is 2.7.13 version for Python. And you can use get size of object. So here I have defined a list, a dict. First I'll take a size of dict, that is a dictionary. It comes 140. This is not actually a size of dictionary. This is a size of empty dictionary because everything in Python is in reference. So I have to add size of dictionary plus size of value inside the key one, that is high, a string. So it gives a total dictionary value 163. And then I'm printing a size of our list. It contains 2 integers. So if you need more information about memory management or about size objects, follow this link. You will get more information in memory management. This is all about memory management in Python. We'll talk about path information, sys.path. So it is basically how Python accesses modules, right? When you say import, how Python goes about it. First is initiated by Python path, but installation default and the current directory all is come from a sys.path. This is how you get sys.path. Let's say this is our file. We're going to access everything. First we'll go importing this, then print sys.path. Then we'll talk about sys.platform, which platform you're using, Windows, Linux, anything. Then exec info. Exec info helps us in getting information about exception. So this is, so let's say when we run this program, some small program, first we get sys.path. Okay, all the packages, current scripts, where we are, Python Central, Python path, and installation default, that side packages, and lib. Then we get platform, that's in 32. Then we have, currently we have defined a list one, and we are trying to access a index in a list, but which is not there. So we get list out of range exception. We print that exception, and exec info gives us the detailed information about exception. That is, it's an index error, what is an error, and traceback object. You can use traceback to get the more details of an exception. Then, so let's say this is just an exec info, but you want to set a trace to your full program. What is exactly happening in what line, where we are right now. Then you can use sys.setTrace function, and you have to pass a trace function, which is a user-defined function to it. So it allows you to implement a code debugger kind of a tracer function in your program. You can use sys.getTrace to get the function set by setTrace. So this is our program. First, I'm printing line numbers now. First, we are importing sys. Then we have defined a trace function. This is user defined system trace function. We have frame event. Our event is call because we are going to get call. Then this whole code format has to be defined, call name, and then let's see. This is our first print line. We are going to print function line number, function name, and from which file. Then we are going to say from where that exactly called. From line over here. If event is line, or like else print style event. That's just function details. Then this is our first function, definition B. We're going to print inside B, and definition A, then inside A, and we are calling B from inside A. Here we are setting our set trace as a tracer function. They are calling A on line 20. Let's see how it works. So first it goes to A. There's a call for A. Line 20 is a functional file. So at line 23, A is called. From where it is called? It's called from line 28 of our file. So this is case line 23 is called. It's called from line 28. Then it goes inside function A, prints inside A. Now after inside A on line 25, we're calling B. So line 19, B is called. From line 25 it is called. That gets printed, and then it prints inside B. So this is how all trace of a call it's printed. This is how you can set a trace function and implement a debugger in your code in SYS module. Now after SYS module, we are going to talk about OS module. OS module helps us to interact with operating systems. So you can use operating system functions using OS module. It is seamless for all the operating system. You can use Windows, Linux, Mac OS, anything. It works well with all. But import OS. First we'll talk about file and directory operations. So let's say this is your file path. You have a test.py file. You want to check if you can access that file. So then there are 4 modes. FOK, that can you, is file exist? ROK, can you read that file? WOK, can you write to that file? XOK, is that file is executable? So here this is how it syntax it. os.access path os.ROK. We are checking, can we read that file? It says true. Yes, we can read that file. It gives true or false output. This is you can get the current working directory. In our case it is PyCharm projects. You can change the directory. So let's say you're currently working and you want to change the directory and execute some code from there. You can use CHDR. That's how you do in Linux. Same here. You can change directory from users to dstudy. Change mode. This is a little tricky here because Python usually use octet values. So when before changing mode, you want to know what is the current mode. So you have to use stat, get the stat for the path. If you just print over stat, it will give you so much results. Stat mode 332, this is an octet, and it gives access time, modified time, creation time, GID, and we don't need that much. So this is the way, syntax oct os.path, parse it and get from last 3, you get 666. The mode. Now you can change the mode using stat as read user, read group, and read other. You have to pass it like this to change mode. You get 444. Directly numbering will not use. You have to use the stat module for changing mode of a path in Python. So this is a little tricky. You have to remember this. Then change owner. So for changing owner, we need UID and GID of the owner. So let's import pwd import group to get password user ID. So for pwd, we get username, get UID. From group we get GID, and then both of them we will pass it to the change owner for a particular path, and we can achieve the change owner UID and GID for a particular path. This is the simple code you can use to change owner, UID, and group for a particular path, a particular file. Let's say for test py you want to change something. Then we'll talk about some directory commands. List dir will list all everything in a particular directory. Mkdir will create a directory for you. Default mode is 077. This is way OS make the directory name. Default mode is 777 for Python. mkdir creates recursive path. So let's say you are creating C or any slash scratch and then another 2-3 directories, but all these directories are not there. It will recursively create all the directories in a path. os.remove will delete a file path. os.rmdir remove directory will delete a directory only if directory is empty. If it is not empty, it will not delete, it will throw out error. Same way remove dirs delete recursively only if everything is empty. All the directories from bottom up approach should be, it's a bottom up. It deletes leaf first and comes up, but everything has to be empty. And if you want to create a symbolic link, you can use symlink source and link name, and it will create a symbolic link for you. This is the general functions for OS module you use. Then this is very important, os.walk. So let's say you have a directory structure and you want to traverse through it. You want to see the whole tree structure of a directory, what is inside is. Then you use os.walk. So it walks from top down or bottom up. You can take any approach, but generally top down, it will from top node to the bottom leaf, it will go. So this is a simple code for file. os.walk base directory print and print file. So I just said file, but this is actually a tuple which contains of 3 parameters: directory path, which is a string, and then directory names is a list of directories inside that directory, and file names inside that directory. So first, the study Python is our base path. Books is a directory under this, and inside Python these are files. Then it will go to the books, and then there is another folder, new folder, and it will list all the files inside it in a third. So this first is directory path, second is a directory is inside that directory, and third is a file inside that directory. This is the tuple, and third it will give everything under new folder. As you can see here, the base path and then only the directory name comes. So if you want actual path, you have to concatenate both. And one more thing to remember, this is a depth first search. os.walk does a depth first search. Now we'll look at process operation. You have os.environment to work with environment variable, get PID, get GID, respective to process ID, group ID, then UID for user ID, get login to get the logged in user. Uname is similar to the uname command. It gives sysname, node name, release version, and machine info. Abort will send a abort signal to the current process. os.kill will use to kill a process. os.fork used to fork child process. And then we'll talk about os.path. This will be, you will be using most. Let's say consider this is our path, into.txt. It's os.path, that absolute path gives you normal absolute path version. Even if it's a symbolic name, it gives the absolute path for it. This is not a symbolic, so it just gives a path. os.path, that base name gives the file name, that is a leaf name for us. os.path, that real path. So here you have to path and a starting point. So d.study is our starting point. It gives the relative path after that. It's just Python intro. .dir name gives you a directory name for that file. If os.path that exists, this is usually used. If os.path that exists, then do these operations in your program. So this is to check if the path exists. Then get c time gives you creation time, get a time gives you access time, get m time gives you a modified time for a particular path. Then os.path that get size gives you a size of the particular path of file in bytes, 105 bytes. os.path that is file, is directory, and is link checks particularly if it is a file, if it is a directory, or is a link. os.path that join, I suggest tell you to prefer use this when you are joining two paths, because let's say you have a directory and you have a file. Use os.path.join, because it is like there will be always an issue of slash, front slash or back slash, which operating system you are using, Windows or Linux. So Python takes care of itself if you use os.path.join. This is how you join both the paths, and os.path.split will help you split the path, splits directional directory and file and separately. This is all about os.module. This is all about SYS and OS module in Python. Thanks for watching.